In this video, I want to show you how to calculate the expected return and variance for a security when there are different states of the world. So suppose there are three states of the world: recession, normal growth, and high growth. And we've assigned probabilities to each of these states of the world. 25% chance of recession, 50% chance of normal growth, and 25% chance of high growth. Now, here are some returns that are that occur during each state of the world. -5% in a recession, 12% normal growth, and 14% if there's a high growth period. Now, you can't just add these up and divide by 3 to get the average, because then you would be weighting the recession return and the high growth return too heavily and not weighing the normal growth period enough. So what you do is you multiply the probability times the return in that period or that state of the world, and you do it for each one, and then you add them up. That's how you get the expected return. So this is going to be the probability times the return. So you can do this simply by multiplying this times this. And let me just add a couple decimal places. It won't be any more. There we go. And we'll just copy those values down, right? 50% chance of 12% is 6%. 25% chance of -5% is -1.5%, and then we just add these up, and we can use the sum function here. Okay, so if you look at this toolbar here, if you don't see anything, if you click these dots here, you'll see this sigma, and sum is one of the choices, and then you can just highlight these, and you get 8.25%. Okay, so this is the expected return. You can also calculate this using something called SUMPRODUCT. So what SUMPRODUCT does is it will do the multiplication for you and then add them all up. So instead of doing this in 2 steps, we can use something called SUMPRODUCT. And we would say we want to take these values, this array, times this array. And what this is going to do is multiply this times this, and add it to this times this, and then add it to this times this. We should get the same answer. And sure enough, we get 8.0825, or you can put this in percentage terms, and we get the same value. Now, to calculate the variance, we can't use the canned package. We can't use VAR or VARP or VARS, because that's not going to do it correctly. What we want to do is subtract the actual return from the expected return, square it, and then multiply it by the probability, and do that for each value, and then we sum them up. So here we're going to have return minus expected return. Actually, let me say that we're going to square these. And you can do this in several steps if you want to, but we're just going to do it this way. So I'm going to say equals this value, let me put in a parenthesis, this value minus this, and I'm going to hit the F4 key to lock that cell, because when I copy it down I don't want it to change. And I'm going to hit hat2 or caret2 to square it. And then I'm not going to copy that down. I'm going to do this. I'm going to copy it myself. And so we get these values, and then you're not done yet. We have to multiply by the probability. So again, here we go. So let's take let's take, these are the deviations squared times the probability. So we're going to say equals this times this. And again, I'm going to ignore that, and I'm going to copy it myself. Sometimes it's good to copy it, sometimes it doesn't copy correctly. And then I'm going to sum these up. Oops, forgot to try that again. Forgot to highlight these values. And there we have it. So here we have the variance. And again, we can use sum product as well. So we can say take these probabilities for that array, separate with a comma, times these deviations, and we get the same value. So this is the variance. And if we want the standard deviation, we can simply take the square root of this. So just highlight one of those, and here's the square root. And the reason we like square root is that square root is in the same units as return. Variance is in different units because we're squaring these terms, so it's in units squared. So oftentimes we like to just take the square root of this and get the standard deviation. So this is a really easy way to calculate expected return and variance. And again, you have to be careful. If there are probabilities assigned, you have to do it this way. You can't just add them up and divide by the number of observations, or use the average function and the variance function to calculate these values, because you won't get the right answer.